Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're going to be jumping into an 8th grade topic, finding the domain and range of a graph. Now this will be a little bit different from my previous video on this topic in which we found the domain and range of ordered pairs. If you have any questions about what you see here today, remember you can put them in the comment box below or visit me on Facebook at Tutor Me Senpai. If you have any homework you'd like to see on this channel, feel free to tell me all about it there as well. If you find this video helpful, remember to leave a like, it really helps the channel. And while you're at it, smash that subscribe button and hit the notification bell so you know exactly when I drop my next videos. Well, without further ado, let's talk about what the differences are between finding the domain and range of an ordered pair versus the domain and range of a graph. So if you see my last video on finding the domain and range of ordered pairs, you might remember that the domain is simply all possible x values, right? And in the range is all possible y values. Well, the good news is the domain and range are not going to be changing definitions. Domain is still going to be all possible x values, range is still going to be all possible y values, but we will have different notation due to the nature of a graph compared to an ordered pair. Here's an example. Let's say we had this ordered pair here. For you to find a domain, you would look at all possible x's, right? So, if you remember D, diamond, for domain, that would be 1, 3, 5, right? And in a range, R, rectangle, would be 2, 4, 6. Simple, right? So you see how much work it takes to find the domain and range when you have 3 ordered pairs. Let's imagine you had 10. How long would this be? How about 20, 100, 1,000, right? So you see, this is going to be less and less plausible for us to do when we have more and more ordered pairs. Well, that's exactly what a graph is. A graph is an infinite amount of ordered pairs connected to each other from one number to the next. So we had to create new notation for that because writing all of that down would literally take you the rest of your life and you still would not have enough time. Unlike the notation with the curly braces, right? We're not going to be using that. We're going to be using square braces, parentheses, and a combination of square braces and parentheses. These are going to be the basis for our new domain and range notation. And that's because this is going to be an interval notation instead of a set or a list notation. Interval notation means that we're going to account for all possible numbers in between two numbers. So if you had 1 and 2 here, we would write it with a comma here. And this means we want all numbers between 1 and 2. All of them. So not just the whole numbers as you're used to for the set notation or the list notation. This is including 1.2, 1.3, 1.22222, 1.99999, all the numbers between 1 and 2. Now you might be asking, why do we need all these different sets of notations when we can just use this one? Well, that's because of what these mean. The square braces versus the parentheses mean two different things. So this notation here is very different from this notation because this notation means that we do not include the endpoints. So 1 and 2 are not in this list. Whereas up here, 1 and 2 are included in this list. So if you're counting all the numbers, you would start with 1 here and you would end with 2. In this case, you would start with the next number greater than 1. Now, there are infinite numbers greater than 1, and you can get very, very close to 1. So I'm not going to go into that, but this is just letting you know that 1 is not part of this list. 2 is also not part of this list. So you can see why you have at least these two different notations, and you can potentially see why you have these, because you might want to have one part included in the list and the other part not, vice versa. Right? So this means that 1 is included and 2 isn't. 1 isn't included and 2 is. So we get rid of the notation using the curly braces, and we adopt these parentheses and square brackets in these 4 forms. That is going to be the biggest difference between finding the domain and range of an ordered pair compared to of a graph. We have to use these notations using the interval instead of writing out individual numbers in a set. So looking at our question for today, we have this graph that has a point at 2 and an arrow at 7 as far as the x-axis is concerned. Well, let's break down what this graph means. Whenever you have a point at one end going to another end, that means that we want to include these numbers, right? So let's say, going back to our previous example, this would be 1, 2. If you have a graph like this, well, that's going to change our notation to be the parentheses, because these open circles mean, hey, we want to get as close as possible to these numbers, but we don't want to hit them. So 1 and 2 are not going to be included in this graph, thus they will not be included in this interval. Another form that a graph can take can be the mixture, which we previously talked about. This, we want 1, but we don't want to include 2, right? Vice versa. We don't want to include 1, and we do want to include 2, which will cause us to change this to the following notation. Not only do you have open and closed circles, as you see in our question, you have arrows. Well, what does the arrow mean? Let's say we have a graph like this. We already talked about this closed circle. We want to start here, so whatever this one is, that's going to be our beginning part of our interval. But this arrow means I want to keep extending this beyond. Now, we don't have infinite space on our graph, so we denote it with this arrow to say, hey, keep going in this direction. We're not going to be stopping here. It's going to be continuing down. So if we were to keep going and drawing this into infinity, it would just keep going down. Off the board, off of the continent, just keep going, right? However, we don't have that luxury, so we just write the arrow. So for our interval notation, we want to have the closed brackets, right? So this is 1. We want to have a 1 here, but we don't have a number here because it doesn't stop, right? It doesn't stop. So we're going to actually keep going to infinity. Now, can you ever grab infinity? Is infinity an actual number? No. So we're not going to have a closed bracket. Instead, we're going to have an open parentheses. That's what that means, an open parentheses. We don't ever get to infinity, but this arrow tells us to keep going. Don't stop. There's no particular number we're stopping at. We're going to keep going. So we will read this as 1 and infinity. 1, we're starting here, and we're going to infinity. Now that we talked about the notation that we're going to be using and the different forms of the graphs that we're going to be seeing, let's tackle our question for today. Now, you might have noticed that I didn't mention anything about domain or ranges when I was giving the examples of the notation and the graphs. That was just to give you an idea of how they're going to be used. Now you're going to have to apply the definition of the domain and the definition of the range when using these different notations. We're going to start with D because D comes before R in the alphabet, thus domain comes before range. So our domain is going to start at the x value, the first x value. And on our graph, the first x value we have is a -2, right? Now, we have a circle, but it's a filled in circle. So that means that we want to include 2. So that means we're going to have to put a square bracket, right? We want to include 2 in the domain. Now we keep going, and do we want to stop at 7? No, right? Because it's not an open circle or a closed circle, we don't stop at 7, but instead, this graph is telling us that the x-axis is going to keep going. That arrow means keep going on the x-axis. But that arrow also has an implication for the y, because as x keeps increasing, it looks like y is also increasing, right? But for domain's sake, x is going to keep going, and since we can't grab hold of infinity, we're going to have to put the notation of a parentheses here. Now looking at range, all possible y values. So what is the lowest y value that we have? So the lowest y value seems to be a -4. Now, does it hit -4? Yes, right? So we can actually put that in a square bracket as well. Now, the highest y value. Well, we have a y value at 2, right? When x is -2, we have a y value of 2. But does that mean it's the highest? No, because if you look at where x is 7, we have the arrow once again. And it's showing us it's going to keep increasing to infinity. So, as once again, x goes to infinity, y also goes to a positive infinity. Going to get larger and larger, and we can't grab it. So this is going to be our notation. A infinity here with a parentheses. So all possible x's, remember this is the interval. We're starting at -2. There is nothing smaller than -2 on our graph. And we're going to be getting infinitely large. There is no cutoff. Because of that arrow, we're going to get bigger and bigger x's. Whenever you have an x, you can always get a bigger one. Same thing for a range. The absolute bottom seems to be at -4. So we include it. But we're going to be getting infinitely large because that arrow is pointing up. So therefore, this has no bounds. Therefore, we give it a parentheses. We don't include it. You can't grab infinity. So we stop with this notation. Domain, -2, included. Infinity, not included. Range, -4, included. Infinity, not included. Well, I hope you're able to follow along with today's example, and I hope I didn't lose you when we're talking about the differences between find domain and range of a graph versus the ordered pair. But it's imperative that you realize there is a difference. The notation is vastly different, and it means two different things. If you have any questions about what you saw here today, feel free to put them in the comment box below or visit me on Facebook at Tutor Sempai. You can always tell me about your homework there if you'd like to see it on this channel. If you did find this video helpful, remember to leave that like. It really helps the channel. Also, while you're at it, hit the notification bell and smash the subscribe button just so you know exactly when I drop my next videos. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Sempai.